welcome to the show. It's me, John Park, and it is time for another John Park's Workshop. Thank you for coming to the show. I am back. I was out last week for the Thanksgiving holidays, and then I was back for my show on Tuesday, which we'll talk about in a little bit. And now here I am for the first workshop show in a week or so. So thanks for stopping by, and hey, thanks Charles Burniford and Connor McCarter and Dave Odessa over in the YouTube chat. Hello and welcome. And where are the other people? Well, if you're chatting or trying to chat over on Facebook or LinkedIn or some of the other places that we broadcast, Twitch, and you're wondering where people are, they're probably over here in the Discord. This is our Discord server. We have a live broadcast chat room. And in fact, I have that kind of cropped off. Let's take a look at, if I can widen that image there a little bit. Let's, there you can see. Can you see that now? Yeah, you can. That's our full complement of channels that we have here. And this is the live broadcast chat channel that you want to hop into. We also have live broadcast announce that lets you know when shows go live. I'm a little behind on scrolling through that one. And then we have general chat, off topic, help with a bunch of different topics, including CircuitPython, 3D printing, Adafruit I/O, Arduino, and on and on and on. So head on over to our Discord and hang out. Why won't you? Why don't you? Why shan't you? Fancy English. Let me squeeze that back over there and update that. There we go. Please don't pay any attention to Lars. Don't encourage him. I don't know what he's up to back there. So my batteries tried to die right before the show. They tried to trick me, but I caught them. I was able to change out my battery pack for the microphone right before it croaked. Hi, Thin Man. Hi, Dexter Starbird. Yeah, there was a bit of a puppet show last night because we had Odd J on with his new mechanical owl that he's putting up some tutorials on this Maker I/O. Is that the right one? And that's part of DigiKey. I think it's Maker I/O, right? Someone tell me. The table does look clean, mostly. What's this one wire doing here? Let's move that there. Yeah, there was a flurry of activity before I left on our trip, and then I was able to clean it off a little bit. Mike P, hello, Gary Z, Andy Calloway, and our good friend Steve, hello. So, oh my goodness, Lars is now available in a handy 6-pack. That's upsetting. All right, let's see, what else? Hello from Texas, Connor McCarter. One thing I'll mention is we've got a jobs board over at jobs.adafruit.com. You can head on over there to take a look at some of the available positions as well as have a look at individual resumes if you're looking to hire someone. It is right here at jobs.adafruit.com. It's entirely free. Just sign up with an email address and costs you nothing to post. If you're looking to hire someone, it costs you nothing to put your info up there, including your resume and relevant work experience if you're looking to pick up some work. So this is the jobs board, and there's plenty of stuff going on there, so go check it out. Let's see, what else? Oh yeah, you know, I've got this show. This happens on, there we go, Tuesdays, and it is my JP's Product Pick of the Week show. It looks a lot like this. This week it was this very cool Stemma speaker and amplifier. I love this thing. You've probably seen me use it before, especially when I'm doing projects with a Circuit Playground Express or Circuit Playground Bluefruit, and I want something a little better than the tiny little speaker that's built onto there. This has the amp and speaker, and so it's super convenient for just hooking onto a project really quickly or testing something out. Here's a little 1-minute recap, and the thing to know is that during the actual live stream on Tuesday, this was 50% off, and we usually do that with the product picks. We get a deep discount on them, often 50% off, so a good time to get some cool gear. Take it away, me. Stemma speaker It is a speaker and amplifier that's super easy plug and play. You can add it to a ton of different microcontroller boards and projects that need a little amp and a speaker. I've got it hooked up right now using one of our Stemma to alligator clip cable assemblies, and I have it hooked up to a Circuit Playground Bluefruit, and I'm running the signal over this audio pin here, which on this one is actually PWM, but you can use it with boards that have a DAC as well. And what I've got are a couple of buttons here that'll give us some sounds. And so you can see you get quite a big difference by having that pressed against something, which is how these little speakers are meant to be used. The Stemma speaker breakout board with amplifier. And yeah, if you did get a chance to decode that, you probably came up with 8675309 as the number that little device was trying to call. And if you are not aware of that song, look deep into your past in the 80s to a song, what was it called, Jenny? That might have been the song. 8675309. I'm only going to sing it down that low today because I've got a bit of a head cold. That was the consequence of travel. I braved and survived airline travel over Thanksgiving, and I did get a little bit of a head cold, but I think I'm through the worst of it, which is good. All right, let's see what else. I think this is a good time for the CircuitPython Parsec. Circuit Python Parsec. All right, let's get set up for this. And I'm going to plug in this board to make sure everything is up and running happily before we start. I had a fun crashing story earlier I'll tell you all about. Let's see, there's Atom. And let's go and open up. It doesn't want to show up. I think it might be under a different, yeah. All right, not quite ready. Let's open up the, oh, that's weird. I broke the board. Oh, no, I didn't. There we go. Wrong code. Okay, sorry. This will be a slightly protracted setup as I go grab that file from a different place. Yay. Okay, this should work. All right, good. Here we go. You ready for this? For the CircuitPython Parsec today, I wanted to talk about how to do a very simple but important thing, which is serial printing without the new line. So if you're used to using serial print to the USB REPL for your debugging or printing to a screen, one thing you'll often encounter is when you're printing out values, maybe it's sensor values or timings, the numbers kind of whip past real fast and you can't really go back and look at stuff. You can't really scroll that easily. It's a bit of a pain. So if you want to print values but not have the print statement be automatically a print including a new line where it goes to the next line, all you have to do is this. Change your print statement to include comma, end equals, and then some quotes with either a space or some characters in it. If I hit save right here, you will see now I have numbers moving across the screen, and it'll still wrap so it doesn't kind of go off to the right forever, but it means you can keep track of things for a lot longer. So I never knew this until recently. This was a tip and trick from the Toddbot GitHub page, Toddbot's tips and tricks for CircuitPython. Really helpful because now you can go in and take that default behavior of the new line, remove that, and even add in something, let's say a little comma now. Now when I start that, I get these little commas between them to delimit things. So that is a really simple but effective trick for helping your serial output, and that is how you can do serial printing without the new line. And that is your CircuitPython Parsec. Hey, here's a question. Was that audible? Yes, it was. Okay. I was worried that I had never clicked back on my mic, but then I saw no one yelling in the chat that you couldn't hear me. So, whew. Yeah, very neat trick. Really, really useful. And in fact, I wanted to see if that could also be used as a more explicit way to do the new line. And in fact, it is. If you put a backslash and an N, which is the sort of escape character for using a new line, if I hit save now, you'll see it's back to kind of that default behavior. So you can change what that is there, put some dashes maybe, and now it's going to run across the screen with a little custom thing in the middle. So yeah, super helpful trick. Thanks again to ToddBot for his tips and tricks page that he has. In fact, let me show that. I haven't shown that in a while. I know sometimes if Todd's around, he'll put it in the chat. But let me create a new tab in my Chrome browser here, and let's bring that up. Tips, no, let's see, ToddBot. All right, let me bring that up for you right here. So if you go to GitHub and find ToddBot and look in his repositories, you'll see a CircuitPython tips and tricks. Here's CircuitPython tricks. And that has a nice little table of contents, and that's where I found this one about printing to USB serial with style. So thanks again, Todd. All right. Using tabs to get tabular data, you might still want a new line, though. Interesting. Yeah, I guess it depends on if you're trying to format, what kind of use you're trying to format that for. I find this is really helpful for when you've got a analog outlet. So you're testing a joystick or a Nintendo Wii Chuck and trying to find out the extents of things. It's nice to have your data show up in a neat place. All right, let's see, what else have we got? Let's dive into my new project that I'm working on. So you may have seen some, let's switch this screen out. You may have seen some of my little demos in the last couple days of this, and I've been updating and upgrading, and Lady Ada had a cool suggestion yesterday for adding a Neo key to the mix here. So let me move all of that up and plug it in, and then I will fix the focus. And I've also got to add in an application, and I'll tell you why in a second. Okay, so let's get that focused a little better, a little too far. That's pretty sharp. So first of all, without having it do anything that we can hear, what I've got right now are these 4 NeoSliders. So these are essentially a plug-and-play slide potentiometer. And what you see we've got here on the back, a couple of Stemma QT ports or quick connector ports so that you can go to I2C on your main device and then chain that to others as long as they have different addresses, different I2C addresses. I'll show you how you change that in a second. And then this has the ATtiny 817 or 807 chip on it, which is our new chip for Stemma types of things. So this handles all of the reading of the analog pin as well as the writing out to NeoPixels that are built onto there. You can see those brightening up and darkening as I move that slider. And then it just sends those values over I2C in a chunk over to your microcontroller. So these all are chained together and all showing up as different addresses. And I'll show you the code in a second. I mentioned being able to adjust your address. You'll see here there's a bunch of jumpers, little jumper pads built on the bottom there, and they say A3, A2, A1, and A0. So by default, these are actually all connected. So you actually trim these with a hobby knife in order to, instead of putting a solder blob on, you don't even have to solder, you're just going to chop those. And if you chop that little one on the A0, then you'll add 1 to the address. So this starts out as address 30, X0X30. And if you chop that little bridge there, this will become 31. If you just chop the 1, it's 32. Both of them, it's 33, and on up. So you can get a bunch of different addresses and hook up, I think, up to 16 of these, maybe. My math is sketchy there. Let's refocus that. And you can see this also has mounting holes, and it has pins if you want to connect it with soldered pins into a breadboard or into a perf board of some kind. But I'm just using the I2C here, and then I've got these mounting holes that I can use to connect these. So you can see you get a pretty good, not too tight, but not too big. Gives you enough room to get your fingers there without hitting other ones, which is kind of nice. And now you've got the makings of a sort of prototyping DIY controller of some kind that uses slide potentiometers. Now, it could be things like mixing colors in a set of NeoPixels, could be changing animation parameters for NeoPixels, could be changing settings on a robot or motors, could be using it for video stuff. I'm going to use it, big surprise, for some MIDI stuff. But these things kind of apply almost to any use you find. So it could be sending out USB HID instead of MIDI. Could be sending out serial data, serial MIDI, OSC, kind of sky's the limit. And then the addition here to the project since I started showing a couple demos is this NeoKey lady. I said, hey, how about add the NeoKey? It's about the same size. Mine has a little case on here that I had built. But let me grab one off of my little wall of goodies here. And you can see that's the NeoKey there. Similar approach. Has a couple of STEMMA QT, has the sockets for putting key switches in, has underlit LEDs, NeoPixels, mounting holes, and so on. I don't know if the mounting holes line up. I think they maybe do. They do, yeah. So those line up pretty well. They're in fact the same size. I'm guessing there's no that's no accident. And that's why Lady Ada recommended it. Good call. I didn't realize that when I got the NeoSliders. So let's see. If you look at, I'm gonna take the exposure down so you can see the pixels a little better. Something like that, maybe. So you'll see here with my Neo keys, I'm changing the LED color and brightening it. When I press those, I've got a few different kinds of switches and no keycaps on there right now. Sorry about that. Let's see. Yeah, I don't have any clear keycaps right here. So those are sending out NeoKey library-based button presses to my Feather M4 here. These are sending out essentially analog values as I move them around. And then what I'm going to do in code with those is have them send out MIDI. So let's take a look at the code first, and then I'll show you a little demo of this in practice. Dexter's hardboard says you have to add solder to change the NeoKey addresses. Actually, on some of our boards you add solder. On others you actually cut a trace. So you'll see a kind of difference here on this NeoKey. This let me get something to point with that you can see. So on this NeoKey here, we've got those little sort of chevron-shaped pads, and you bridge a solder blob across those to close those addresses. These ones actually are pre-joined, and so you actually cut a trace. Let's see if I can bump that exposure back up and change that focus again. There we go. So you'll see on this one, A0 and A1 I cut, and A2 and A3 are not cut. So it's like a little big fat letter I there with huge serifs. So that's the difference there, and that just makes it easier for some people who aren't interested in soldering or don't have the equipment around, can't for whatever reason, you can change the jumpers a little easier than with this setup. So let's take a look at code on this. And bring up this view of the world. Works pretty well. And let's open up. Excuse me. Okay, so here's what I have going on. Actually pulled out the debouncer. That was causing me problems that I have to look into, slowing things down. But the main things that you'll see here that are of interest are using Seesaw as well as the Seesaw NeoPixel library instead of regular NeoPixel, and the Seesaw analog input. And that's because we're essentially using the little tiny microcontroller, ATtiny, on here to gather up our analog info and to write out to our NeoPixels, and then we're sending an I2C message to it or receiving one to tell it what to do. So there's no GPIO pins being used on the Feather itself for any of the analog stuff. It's all happening local to this board. That's what kind of makes it self-contained or almost self-contained. And then NeoKey is a similar type of thing, but it's all wrapped up into this one library. And so that's what allows me to write NeoPixel values and read button presses, button releases on here, and then send that info over I2C. So what we do is we set up the I2C bus on the serial clock and serial data lines of the Feather. And by the way, I'm using a Feather M4 here, which doesn't have, in this incarnation, it doesn't have a STEMMA QT port. So I decided to use this cool SparkFun breakout board that has 4 I2C STEMMA QT ports on it. Just any board you have with that would make it easy, or you could go a cable that goes from the regular GPIO out. But this was just a convenience here. So then I'm setting up my NeoSliders, and you can see these are the addresses. So the default's 30, then I have 31, 32, 33 based on cutting those little jumpers for address. And then I'm going to set up a Seesaw object. So this Seesaw, and then I'm actually going to make a list of those by creating them in this little bit of code here for address and addresses. It just goes through, iterates 4 times, and makes 4 objects that it puts into this list. So then we end up with SS 0, 1, 2, and 3. This, by the way, is, I think Kattni's working on a guide for this. There isn't a guide yet for the NeoSlider, but I can tell you if you have one and you're wondering, the analog pin on here you want to read is pin 18 on all of them. Each of them have a pin 18 on the ATtiny. That's what the potentiometer is hooked up to. And the pixel pin for writing out the NeoPixels that are built onto here are this pin 14, yeah, pin 14. Then analog pins equal 0, 1. Why am I doing that? I can't remember. Oh, because I'm setting up two of these, right? Wait, what was that about? I don't know why I have that there anymore. Sorry. It might be the cold. Let's say it's the head cold. I can't remember how I'm using that. I bet I'm not using that. I think that's an artifact from before I batched it up. So same sort of thing. I batch this up and create 2 analog input, or actually in this case 4. So for I in the range of the length of this list, which is now contains 4 objects, it goes through and creates the analog pin definition, setting 18 as an analog read, analog input pin. Then setting up the NeoPixels in a similar way. I go through all 4 of these sliders and set them each to be a Seesaw object using the pin 14 of the slider with 4 NeoPixels. And I also set them by default to a kind of amber color. Then we set up the little NeoPixel, NeoKey rather. That's these 4 keys here. And that I set to be on address 38. I did that, again, by setting a jumper under here. This one I did have to solder. I soldered the A3 jumper, so that set it to add 8 to the default. And then I, again, created a color that I could set the NeoPixels to start off at, this kind of amber color. This I'm not using. That's an artifact I'll pull out of there to avoid confusion. Then I set up these keys. So these are a little dictionary that it contains. If we had multiple of these, we'd name them NeoKey 1, NeoKey 2. In this case, I just have the 1, so this is sort of extraneous. And then there are 4 of these keys on here. I set them each to have one of 4 different colors that they can turn to. So this one can turn red, sort of magenta, pink, and sort of peach color. And the last piece of info in here is just what MIDI note do I want them to play if they're going to play a MIDI note. This might be nice to abstract out somewhere else that's easier, but in this case I just gave it hard-coded for 4 different MIDI notes that those can play. Then since I'm using something to check the state if they're pressed or released, I have this little list here of key states. Then I'm setting up my MIDI. This is a little list of slider positions so that we can compare the current slider position to the previous slider position. At first I'm just setting them all to 0, and this is kind of a cool way to do that. You can just say last sliders equals the value in brackets times the number of them you want, and that makes a list called last sliders that at first is all set to 0. Then those will be changed later as we move the sliders around. And then finally I have a little list here of what CC numbers I want these set out on. You can almost think of them as channels, CC channels, but these are the continuous controller or change values that are used in MIDI to adjust different things. And I'll show you those in action in a second. The main loop of the program now, it's kind of got these 2 different chunks. So for the Neo keys, I won't go into as much detail because we've done this sort of stuff before, but essentially we look to see the state of each of those 4, and if one of them is pressed and its state is false, then it'll press. If it's released and its state is true, then it'll send that sort of released signal. That allows me to just send a MIDI signal one time and then the MIDI off signal only when I release it, so it's not constantly spamming. So that's how that state is used. Then here in the slider check, let me hit a couple carriage returns here to get that up higher. Why not? In here, what I'm doing is for the range of the number of sliders, there's 4 of them. For each slider, it goes and it creates a variable called slider that is the analog input value of that slider. So at the bottom here, it's going to be 0. At the top, it's going to be 1023. So let's say that's at 1023. If the absolute value of the slider minus that last slider value that was stored, initially that's 0, is greater than 3, that means we've moved it intentionally and it's not just noise. And you could adjust this value, but this works out pretty well because what I'm going to next do is remap this slider value that goes 0 to 1023 down to the range of a MIDI CC, which is 0 to 127. So no one's going to notice. You'll still get smooth CC values changing even though we're at first needing a change of 3 on the analog read to register it. Then we send that MIDI controller change CC number, which in the case of this first slider is 7, which I think is normally volume on a MIDI device. Unless you remap it, that'll change the volume of it. And then whatever that number is, 0 to 127 gets sent. Then I'm also remapping the color value. I'm creating a color value variable that is an integer based on using the map range function of whatever the slider value is and taking from 0 to 1023 and adjusting that to 5 to 255. So that means that my NeoPixel can be at the lowest 5 on the red channel and 5 on the green channel and 0 on blue. I just decided to do it a sort of simple way. So whenever I change this, I'm just reducing the red and green or increasing the red and green, and that gives me, in the end, this kind of nice ambery color, partly because it's going through, it's very yellow in reality, but it's going through the circuit board of the bottom of the this fiberglass of the bottom of the potentiometer slide pot, which warms it up. It's a sort of ambery color. And I didn't want it to go all the way dark, just so you'd always be able to see it there if you're using this in a darker setting. So I have the minimum is 5 on red, 5 on green. And then the last thing we do is we update the value of last sliders to the current slider value, and that allows us to continue that cycle of checking. And again, it means it's essentially quiet. It's not sending new values when you're not touching it. So let's see. We can do one quick test here, which will just be, let's print the CC val. And I will go into my serial here. Oh, and look, let's use our new trick. Let's see if I can use the new trick here. End equals, there we go. So now it won't be, so you can see there as I change that, it'll go 0 up to 1027. I'm not telling it to tell us which one is sending right now, so they're all going to end up looking the same. So let's take that out of there, though. And the reason is this. We're about to open up a piece of software that's essentially a synthesizer, a modular synthesizer simulator. And I've shown you the previous version of this before. The new version was just released, called Vcv Rack 2. I'm about to launch it. Why am I about to launch it and don't just have it launched already like I usually do for these things? Because it crashes when I write to the serial port for some reason. So I'm going to close this close this serial port here. Whoops. Okay. Yes. So I don't accidentally crash Vcv Rack. And I found that out earlier when I was getting ready to demo my CircuitPython parsec, and it was spamming all those numbers there, and Vcv Rack was crashing, and I figured out that's why. So let me launch that, and then I'll bring up a screen for you there. And let me tell this to show. Hey, it's shown up. All right. And I have it running through an external speaker, so hopefully you'll hear it without me causing chaos on my audio. So let's take a look at, first of all, without even listening to it, if I set up my Vcv Rack here, has essentially a bunch of modules that can do different things, and they can connect to each other and send and receive data and modulate things and change stuff for each other. That's kind of the really high-level view of this, with the goal of generally making some sound or music. I have a little module in here called MIDI CC to control voltage, and I'm going to say that should read my Feather M4 right here. So this is set up, sorry, let me zoom in there a little better. This is set up as a set of 16 different MIDI CC values it can read, and what I can do is customize it so that it listens to my particular sliders. And you can see these are, I had already set these up. But now CCs 7, 49, 50, and 51, which are the CC numbers, or channels is kind of how you can think of them, that these are sending out on, are connected to this module. And you'll notice also the green jack here that we plug things into is increasing and decreasing its green value as I decrease or increase my MIDI. The paradigm that's used inside of Vcv Rack is the same for modular synthesizers and semi-modular synthesizers and synthesizers in general that use voltage. So it's essentially internal to that software. It kind of thinks of things as I'm getting 0 voltage, or I'm getting up to, in this case, I think 10 volts positive, or it might be 5. Some things go -10 to +10, -8 to +8, 0 to 5, 0 to 10, 0 to 8. It can vary. But in this case, it is the maximum. So I can change some other thing, which if you noticed over here, there's one modular in particular which says ADSR. That is attack, decay, sustain, and release. And if you look at the helpful graphic there, those values are changing as I change my sliders. And what these represent are an envelope of sound. So a sound can start, stay sustained at its maximum volume, and then end instantly. And that would look something like, let's see, this. So that's a case where I have an instant attack. I have no decay period. It just stays from the attack value to the sustained value forever. It holds as long as you hold, and then it drops off. If I adjust these, you can see I can now change the amount of time it takes to decay from its attack value to its sustained value, which makes more sense if the sustained value is a bit lower than the attack onslaught. And then if I want it to have a long release, this is sort of not a relative scale. This changes its scale. The timings of the first stuff are the same, but this last thing is now going to release a long time. So let's see if I can actually show you what that sounds like. I'm going to set up the output module here. Where'd you go? To be, yeah, okay. What's missing? You should be playing over that. What value? I've taken some mixer value really low. Oh, I know. I'm not sending any. So let's do one other thing. I'm going to press one of my buttons on the little Neo key. Let me get a nicer sounding one. I've really made this sound terrible. I'm sorry. I was goofing around with stuff. So here's very plucky, starts and stops instantly. In fact, you know what? I'm gonna, should I break some stuff? Let me, do I want to do that? No, I don't want to. All right, so let's just see if we can hear a difference in this. Sorry. I'm going to now increase the attack. Yeah, you know what? I'm going to break a bunch of stuff. Suffice it to say, before I go and break that, if you see these 4 red buttons, those are actually based on my little Neo key. And I'm essentially using those as, there's this module called flow here. I'm using it almost like a mute switch. Do I want some of that signal flow to go through one of these 4 resonators here? But I think that's making it really hard to demo the other thing. So I'm going to take their control away from them for a second, and I'm going to patch this a little more directly. Let's see if I do. So this little oscillator here is what's actually making the sounds, and I'm going to go directly out. Okay. Let me get a nicer sounding oscillator. And let me make some of that pitches a little higher. Okay, that's a little better. So if I adjust this slider here for have a short release, you can hear it's very short, does not have a release to it, it just ends. And if I want to have a really soft, let me raise this, soft intro, I can increase that attack time. Then it takes longer to get to that attack. Let me crank that. And you can even see over in this item here that says VCA that has the little meter, if we have it doing a long decay, and I'm going to slow the tempo down on this real quick so you can see that better. I don't know why I've got such a low level on this. Sorry about that. This meter is, all of my levels are really low, so this meter is not helping me out. Let me clear some stuff out of here. Go away, go away, go away, go away, go away. Simplify. You go away. All right, so now I'm essentially not doing anything with these, right? These are not connected to anything. But what I'll do is I'm going to yank this sequencer out of the mix, and I'm going to yank the trigger from that sequencer out of the mix. Don't need that. I'm going to lower the volume in case that ends up being very, very loud. And now what I'll do is actually take those MIDI notes that I'm sending with my Neo keys here, and oh, you know what? Let me undo a bit before, because knowing which ones I connected them to is not fun. So hold on. Okay, so that brings those back. Okay, so what I'm going to do is I'm going to take these cables that are coming out of here. You can see they'll turn green when I press this note here, which is a E, and that one's a F sharp, and that one is a G, and that one's an A sharp. So what I can do is just run a MIDI. Oh, you know what? Let me make a better MIDI thing. Hold on. MIDI to CC, the most basic one. Okay. So this one is actually a little simpler. Good. All right, let me delete some things. I don't need to worry about which note. It'll do it for me. Let's delete you. Delete you. Remember how I showed the signal state game the other day? This is the same. Like, using modular synthesizers is like playing a puzzle game. So it's part of the appeal. So now this is going to read my Feather M4 for not the MIDI CC, which is what these guys are doing, but instead just for the MIDI notes that are being sent, and that includes the pitch value as well as the gate, which is how is it being sent or not being sent. So if I attach my I don't need a quantizer either. So if I take my volts per octave from there and send it into this module here, and then I trigger the envelope that we've been playing with from this. All right, this will make it a lot easier to demo. So I can. All right, so that's increasing that amount of release time. And if I go a short decay, you'll see when I first press it, it then jumps down to, so it's louder right on the attack, then it gets to this whatever this level is of the sustain, and then it drops off. So if I get, there you can see it jumps all the way up, and then immediately goes to the decay. Also, you can see the lights on here, which are kind of cool. They will show you what phase of things we're in. So if I increase, you should see the lights going from attack to decay, and now it's in the sustain, and then when I let go, it does the release. Now it's spending a lot of time there. We could do a lot more with that. We've done that in some other shows, like adding an arpeggiator to it or having it modal so it only plays notes within a certain mode or key. This is 4 keys. I don't think it's necessary. I just gave it 4 notes that kind of sound good together. And if you want to take this kind of stuff and use it in other ways, it's really simple. So right now, let's say I don't really want to noodle around with this attack. I like the attack, decay, sustain, release there, but I want to use these knobs to change values of the oscillator itself. What I can do is say, okay, the output of this first slider is going to change the timbre of my oscillator. So try a different oscillator and that'll do a different thing. Let's see, which one is that? That is the wave shaping oscillator. So it's a wave shaper. Oh, this 2-operator FM is kind of cool. So it's kind of making 2 sine waves battle each other. Now I can take my second slider here and say I'm going to adjust the morph value, which is another kind of just general name for some modulation that's happening, and it varies by model. And it's kind of cool to check out what those waveforms look like. So let's open up an oscilloscope. By the way, this is free software. I'm not paid to endorse it. I just like using it, in case you were wondering. But I feel good about it because it's free, and you can go and download it today. Just look for Vcv Rack 2. There's a paid version that I think can be used as a multi-channel VST inside of other applications, but this is just the free one I'm using. So let's take the output of that oscillator, or that's fine. We can do it even when it's not playing because the gate isn't open for the VCA there. We can take a look at what the wave looks like. So you can see there we get a really smooth sound because there aren't many harmonics. It's a really smooth looking wave. Then we can start messing with it. Now it's wave folding. Now it's a sine. Now we multiply. One sine against the other. And you can get lost in this and play with this all day. I don't know if there's any others that are particularly, let's see, maybe let's do this chords. Okay, so this one creates chords, and not only does it create chords, but the wave shapes can change, as can the voicing of the chords, so this changes the voicing. And so I'm going to use a third slider here instead of the sustain. Now I'm going to adjust the harmonics knob, which I believe is the one that changes which chord you're playing. So let's drop that down, and that should work. Yeah. Oh, you know what? I got to bump up my... Since I'm unplugging things over here, it's using defaults I don't love. So that's a different chord than the others. Now this will be the same chord but voiced differently. Which just means which notes in which octaves are played, even though it's the same notes. kind of goes through the overtones there is almost what it sounds like. And then, yeah, we could take this last one. There isn't actually a kind of sane thing to plug it into on this oscillator, but I'm going to put it into the model category, which changes which of the different possible synthesizer models that are built into this one. This one, by the way, is based on the Mutable Instruments Platts, which is a digital oscillation sort of sound source module that has a bunch of different models built into it. It's sometimes called a meta oscillator or a, yeah, meta oscillator, I think is the name for it. So now this last one will change which model we're using, so it'll get very, very different sounds. So you can see this is just changing these buttons. You can see the LED traveling up and down on this center row here. Some of them are drum and noise based at the red section, so they might not make sense to play this way. This is like granular synth stuff, particle noise. You get that kind of bubbly. That's fun. Woo! All right. So I think that hopefully has inspired you a little bit about both finding a fun thing to play with on the side like this VCV Rack, but also just making a physical interface in your microcontroller world that you can use on your computer. And if I go back to this, if I undo some things here and get back to controlling my ADSR, you can see here this is a lot quicker to go and adjust those 4 parameters with a set of sliders than it would be going with one mouse button at a time. Some people use touch screens with this, I think, and that could get pretty fast. But it's nice and satisfying to have a slider stay where the slider stays until you decide to go and touch it. So I'm a fan. Dexter Sarber says it's nice, but can you play Street Chicken on it? And Steve Hook says yes, likely. Yeah, I don't have it loaded up, but yeah, there's sampler modules. I guess I should load that in as a sample or transcribe my song to somehow play in here. What did I write it in? I don't think on here. I can't remember now. Maybe that was done on Vcv Rack. So let me know if there's other thoughts or questions over in the chat. I'll bring up our Discord here. Before we finish up, let me see if there were any I missed. Someone says, yeah, how much you can do on a Stemma QT. You sure can. You can do a ton. A couple of little sort of things that are in progress and gotchas. We found some issues trying to run these NeoSliders on RP2040, so we're going to be looking at that. I think Dan H. is getting out his logic analyzer to see what was going on. Just a heads up, if you're using this and you're running into problems, try it on a M0 or an M4 or other things. Those are the 2 I've tried it on. That's just for these, and so I'm not sure. It could be to do with the fact that this one has the ATtiny instead of the SAM D9 or whatever we used in the previous Stemma stuff, and that's a shift to our Stemma things. So I'm sure we'll get that working because that's a much more available chip for us. Steve brought up in the chat this is kind of like an RGB version of the 16N, which is a really cool 16 fader board that's a DIY project. You can buy them as kits or source them and make them yourself. Runs off of a Teensy 3.2 and has 16 sliders that can send MIDI, CC, and even I2C info. How many addresses available on the NeoSliders? Ooh, this is a good one. This is a fun one for the chat. We have 4 jumpers. They add either 1, 2, 4, or 8 to the address, and you can use them in any combination. So how many addresses does that give us? I will leave that to the chat. If I try to do it, I'll embarrass myself mostly, but Yeah, so this one adds 8. So you can do a lot. How about that answer? In fact, Steve, I think if we look at the page, let's look at this web page. If we look at the page for the Learn Guide, here, let me bring this up. You'll want to see this. If we bring up Learn Guides and I look for Neo Trellis, we did a graphic. I think I based it on one of Steve's graphics for tiling. So this one has, you can do up to 32 of these. And the question is, how many address slots does it have? And I think I put a chart up here based on this cheat sheet. Yeah, there you go. So this one has more, because this one has the A4, which adds 16. Okay, so that won't answer it for us. Drat. But yeah, it's a cycle. There's Steve. Okay, you're on asking me a question. I'm just going to point at your link on lines where you created a thing. 4. Steve says 4. Yeah, it has 4 jumpers. That's right. I don't know what that math is. I'm no good with hex math. Like I told someone the other day, I don't have 6 fingers. I do have 10, but I don't have 6, so I'm no good at hex. If that computes. All right. I think we've done it. I think we've exhausted our supplies. I never even walked over to the bench today. Let's head over there since it's sort of cleaned off. Ooh, that's kind of dark. I can head over here and do a whole lot of nothing. Anything to talk about over here? Hi. And nah, nothing happening over here today. Clean bench and it stays that way. It was all at the computer today. But I think that my next step with this will be to come up with the some measurements and spacing to put together your own little board of stuff, especially now that I know this has the same mounting hole spacing. We can make a cool little, give it some space like that, have a little 4 buttons vertical like that, and 4 sliders, microcontroller, kind of cool. Yeah, Lars did lose his hat. What's he doing there? And hey, did you know that we have these in the store now? I think only the linear one is left, but remember I was playing around with those, and now Adafruit is selling them, so go check out those big giant keys. They're pretty cool. All right, 64, Connor McCarter says. 64 question mark? Maybe. I think it might be 32. I don't know as far as power goes, 4 NeoPixels per, how many you can drive just off of your normal microcontroller. You might have to add external power at some point. At least 6. Where's my math people? Math is hard. I don't want to do the math of that. So if it's 30, so if we have 1 address, we get 2 of them. If we do that by itself, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? I'm sure I just embarrassed myself and did that wrong. Mike P. asks, is the slider basically a linear version of a rotating potentiometer? Yes, it absolutely is. And it's almost the same mechanism on some level. There's 2 tracks that are offering a connection to ground and power, and the on both ends. So you got your wiper, which is measured and that's moving, and essentially is decreasing the resistance towards the end it's getting closer to. It's increasing the resistance of the end it's moving away from, vice versa. Take all that and loop it into a circle, and that's what the potentiometer is. Not 100%, but basically that's it. Still no math answers that anyone is super confident in. Research is needed, Connor says. Yes. I bet Lady Ada has that answer off the top of her head. She probably even said it in the new segment. All right, we'll get back to this. Phil Wilshire asks, hi, I have a 2.8 pi TFT display. How do I connect this to a Pi 4? If that TFT display is designed for the Raspberry Pi that has 40 pins, it's still the same connector on all of them. So I think that would just connect and it'd be more a question of software. But if anyone has experience with that specific one, or if you've run into a problem with it, let us know. You can also bring a question like that to the chat. If you head here to the Discord, there's, I think, help with Raspberry Pi right here, and that might be a good place to go and check that. Hey, we got an answer from C. Grover, and his answer looks succinct and confident. It is 2 to the 4th power, so 16. Love it. So you can do 16 of these. As far as the number of addresses, the bigger question then will be your NeoPixel. If you can do 16 times 4 NeoPixels at full brightness off of just the power here, that I'm not sure. So you may need to supply a little more power or keep them dim. You know, you don't always have to go full crank with them. And that's another thing about NeoPixels. They have 3 or 4 LEDs in them. If you are just dimming red up and down, you're using 20 milliamps. If you're going from black to white, you're using 60, roughly. Dexter Starboard also had the same math. Thank you. I missed that. You said it right away, didn't you? Good. All right. Thank you, everyone. I'm going to go get over this cold, and I will see you next time. Thanks for stopping by. Be sure to stop by tomorrow for Scott's deep dive with Scott. He's up to something not bare metal CircuitPython on a Raspberry Pi this week, but maybe some of the Bluetooth Python flying over the air to code wirelessly. He was showing off something last night that was really cool. All right, yes, thank you so much. Thanks, Dexter. I hope I feel better, too. I'm going to drink some hot tea. That's what I need. Thanks, everyone. See you next time. Bye-bye.